Hello everyone. So this time we are going to take this question, maximum sliding window maximum. Okay, we will go through the question statement, but before that I am gonna tell you that I put more than half hours to try to understand it or try to feel it. Okay, and I wasn't able to it was really too difficult. Now I am getting some idea how to solve it. Okay, and I also planned something after half an hour, so I'm coming back and making this video, and now I will try to do everything, like try to solve this question from initial. Okay, so let's take this question without any taking more time. Okay, so let's at first let me go through the question first. Okay, so there is an array nums. Okay, this is really good question, like this is really what you here in this question it is all about how greedy you can be or how efficient you can be, and how strategically you can optimize and store the values. Okay, it will give you all. It's a good question, hard category question, but it's a good question. It's an interesting question. They should also put interesting instead of using hard in here. Okay, so let's see. So there's an array nums. Okay, given that this nums will have a k window size. Okay, and which that window will move from left to right. Suppose this is our first input, 1 3 minus 1 minus 3. Okay, let's, yeah, 1 3. Okay, 1 3 minus 1 minus 3 5 3 6 7. Okay, now we have k is equal to 3. K is equal to 3 means first we are gonna take this window. Okay, 1 3 minus 1. Next we will slide it from left to right, then this window, then this window. Okay, then and then this window, this window. Okay, so there are multiple windows starting from this, like total if length of nums minus k windows are there, minus k plus 1 windows are there. So how, okay, so these are the windows. So what's the question is, you only can see these k numbers. Okay, we don't have access to these. You only can see these k numbers, and each time the sliding window moves right by one position, return the maximum of sliding window. So in here the maximum is 3. In this sliding window the maximum is 3 again. In this sliding window maximum is 5. In this sliding window maximum is 5 again. Here it's 5 again. Sorry, it's 6. In here the last one you will have 7 as maximum. So 3 3 5 5 6 7. Okay. Okay, so to solve this question we can simply see that order of n into k is possible. Like every time go through n each of the windows and traverse all the k's. But what we want to do is it is an order of n. Okay. So to achieve this the solution in the order of n, what we can do? Okay, what we can do is yeah. Now here comes one thing. What we can say, an introspection. Suppose we have this one. Okay, the next one is 3, the next one is minus 1. So after 1, when we got 3 and the window is same, we know we don't need this one. 3 will suffice as our answer. Okay, when we go to minus 1, we know that 3 will be its potential answer, so we can move further. Minus 3. So here we see that minus 3 is less than minus 1, so we don't. Okay, minus 3 is less than minus 1, so we will keep it somehow, or we can pop it out also, because it is okay, it can be the answer for this window. Okay, suppose this window would have minus 3 minus 9 and minus 10, so it could be answer of minus 3, could be answer of this window, so we can't pop it out. Okay, then the next is 5. So yeah, 1 second. So the next is 5. So 5 will be the answer of this window, so we can pop it and we can use 5. Okay, no, we can't pop. Yeah, we can pop minus 3. we can pop this -1 too. Yeah, we can pop this -1. Okay, we can use 5 instead. 1 second. So, okay, let's try to think over it. What we have is, okay, let me take another pages. Yeah, can't we move this one to up? See, yeah. So at the end we have this. What we can do is, here there is a 1, here it's a 3. What I was thinking is, every time whenever I found any greater element than the any lesser element than the next one, I will pop it out. Okay, and append 3 as an answer. Yeah, suppose we are having a queue. Okay, a double-ended queue you can say, but a queue. Suppose we have a queue. We will input 1 inside it. Instead of, see, there's one rule. Whenever you are trying to solve any question related to left pointer, right two pointers, or stacks, or queues, or what window, okay, sliding window, always take the indices inside the window. It will help you. So the index of this is, let me mark the indices also. So index is 0, 1, 2, k. Sorry. Control Z. So here it is 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. Okay. So can we copy it now? We don't have anything to copy. Okay, let's just copy it from here. We'll see. Okay, this is the answer. No, it is the real. Let's copy it. Yeah. Okay. So it is. Let's now mark it with it their indexes 1, 0, 1, 2, 3, 4, 5, 6, and 7. Cool. Now we will put 0th index inside queue. Okay. Suppose this is the queue and this is the first one. Here there will be end. We will put 0 inside it. Now we found that the next index, difference between these and these are not k till now. 1 and 0 is still the same. K. We will go to then 3. We will push 3 inside it now. Instead of 3, we are gonna try to push 1. But we found that the difference between 1 and 0 is still 0. Sorry, difference between them is 1. And we can go till at max k. So we can put 3 inside k. We can pop this and put 3 inside. Yeah. So instead of 3, we are gonna put 1 inside. Okay. We can start our whole journey from 0, 1, 2. Will it be? No, it won't be. Okay. Now the next is 2. So we found that -1 is less than 3. So we have to put it inside. The next is 3. So -3 is less than -1. Okay. So we have to put again it inside 0, 1, 2, 3. Now the next one is 5. So 5 is greater than -3. It is greater than -1. So okay. Now we know that for these the answers can't be -1 or -3. So we can pop these two out and can put 4th index. Okay. Now the next is 3. 3 is less than 5. So we are going to append 3, I mean the index 5. The next is 6. So 6 is greater than 3 and greater than 5. So we can pop. Okay, one second. We can't pop these out because because these are the answers for the previous ones. Okay, what we can do then to make it as answer of 5, 3 and 6. We can't pop it out. We can't pop 5 out. Okay. But see, how many of these we have popped out? For 2, we popped out this. Okay, and we know that, yeah, we can do one more thing. We can check the current length, the current difference between case and. Okay, it is taking time again. One second. Okay. So all we know that we are going to put indices. So whenever we put an index, let's print some of the things out to understand it in a better way. We are going to put the index. Okay. Check whether the difference between the first index and the current index we are working. Okay. If that difference is greater than k, we will pop the current one out and use it. Yeah, that's the, okay, yeah. So let's do it again. Let's do everything again. Suppose we have initially 0. Yeah, we put 0 inside it. Okay, we check the current I. Current I is 0 also, so we don't need to do anything. Next we check what is the next one. Okay, next is 3, such that, so next is 1. Okay, so pop this out and put 1 inside it because it is greater. Okay, and whatever is popped, yeah, we have to check whatever is popped. Okay, no, 0, put 1 inside it. Next is -1, we can't do anything. Next is -3, we can't do anything. Now when the chance, okay, so sorry, was first index, then the next is second index, we can't do anything. Third index, we can't do anything. Now we have our fourth index. Now the difference between 4 and 1 is 3 already. So if we are gonna put 4 inside it, okay, let's see. For this answer will be, okay, let's put 4 inside it. Okay, and pop this one out and append this as an answer to 0, as an answer to first window. So 3 is answer to the first window. Now we are left with 2, 3 and 4, such that -1, -3 and 5. Okay, but the answer to the second window is also 3. Yeah, so then what we will do? Okay, yeah, so here we will now put the next index. Next index is, okay, if -1 was there, we can pop it out because 3 is already, okay, no, we can't pop it out. Okay, we put the 4, but now we know that the answer can't be 3, so we will pop 3 out, we will pop 2 out and put 4. Okay, and again, yeah, and again we will check the last index. So the difference between last index is 4. Okay, so we have put the 4. Okay, so what we can do is 0, 1, 2, 3 and 4. Okay, so if 0 is there, then 1 is there, then 2 is there, we pop the 2. So whenever we are popping it, we can't pop all of them. Yeah, we can pop all of them, but we will check whether the, yeah, one second, I got it. This time I got it. Okay, we got it. So at first we will put 0 again. Let's see it again. So we are going to put 0. Then next is we are going to put, okay, we try to put 1, then we found that this won't happen, so we'll pop it out. The next we will do is we will try to put 2. Okay, so we are going to put 2. We can start, yeah, so 0 is there, 1 is there, 2 is there. Okay, then there comes 3. Now 3 is there. But when we have 3, okay, -1, okay. So when we will have our 3 or when we will have our 2, whatever. So here the I minus k will become, when it will become 3, then we know that this is then we know that the first one remaining is in the queue is our answer. So we will pop it out and put it inside answer. So 3 is our answer at first answer. Okay, 3 or the index 1. Let's put our indices only. So 1 is our answer, or rather we can say 3 also, no problem. Now, okay. So this time we put 0, 1, 2, 3. Okay, 3 -1 -3. The next turn is of 5. But when we are trying to append 5, we will check. Okay, 5. Okay, before appending 5. Oh no, we have to do this when the difference is I minus k is equal to, not 3, sorry, I minus, not like this. Whenever I minus k will become -1. Yeah. No, we can't do that also. Whenever I minus k is equal to 0. No, 1 second. Whenever I minus 1 is equal to k, can we do this? Yeah, we can. So whenever, like, when we come here, okay, we will append our answer 1. When we will come 0, 1, 2, we need to append this answer. Okay, and after appending this one, we can go to next. Okay, we will check now again. 3 is already there. We will go to 5. 3 is popped out and everything is popped out. Current answer will be 5. So we are going to append 5. Next is 3. 5 will come. We can't pop it. Okay, we will pop again. We will pop out 5. Yeah. Finally. Okay, this algo will work. Let's try to implement it. So I guess you can understand it now. So whenever we are going forward, after, yeah, whenever this I will become k minus 1, we are gonna start appending the first element of q. That's the thing I was missing for a long time. Okay, so let's try it again. So we will need a q. Okay, q is equal to, we will need a q. Now we have to traverse the whole nums, so we can use our I comma val in enumerate. We can use enumerate nums. Okay, I comma val in enumerate nums. Yeah. So next thing is, if nums of, no, instead we should use if q and nums of I is greater than or equal to q of last element of q. Okay, then just q dot pop. Okay, and at the end append whatever. 1 second. Yeah, if it is greater than this, then pop it, and at the end append append the nums of I. Okay, so we are going to put indices inside it. We must remember this part. Whenever there is a question related to sliding window, max window, or stack or queue, try to use index, it will help you. So nums of q minus 1, okay, yeah. If q and nums of I, okay, again I'm using, okay, let's use simple for loop for I in range length of nums. Okay, so if q and nums of I is greater than equal to nums of q of minus 1, okay, then q dot pop, else q dot append nums of, not nums of, q dot append I after this. And if the end of q such that if I minus q of 0, if the difference between them is, let's see, every time we have to pop some of them out now. So if the difference between these and these is equal to k, okay, then pop it, because it won't work. Like this can't be a solution for minus 3. Okay, so if the difference between I minus q0 difference is equal to k, then q dot pop 0, pop the 0th index. Okay, and at the last, if I is equal to or I is greater than equal to k minus 1, okay, then we will have our result array. Result is equal to result dot append I. I is greater than equal to k, so we can append directly nums of I. Yeah. Okay, so we have to count it or what? No, we have to return the result now. Okay, 1 second, there's a glitch. Yeah, so at the end we can return our results. Let's see whether it's working or not and debug the code. So whenever you are trying to code, at first write the pseudo algo. Don't be like me directly trying to solve the question, because I have already solved so much question, so some of them are easy, so I directly took it directly. I directly tried to solve it without doing that much analysis, but you should do. So what's the problem? -1 and -3. 1 second. So if nums of I is greater than nums of q minus 1, then pop it. If I minus q0, okay, then pop it. So what's the problem? It is just appending the last one. Okay, let's see. If I is greater than equal to k minus 1, suppose I is -1, okay, then append the first, append nums, sorry, append y, I'm not appending nums of I, append nums of q, okay, q dot pop 0, yeah, q dot pop 0, 3, okay, cool, -1, why -1, it should be 3 again. Okay, let's try to debug our code. If nums of I is greater than nums of q minus 1, oh, we have to use while loop here, sorry. While it is happening, just pop everything out. Okay, again 3 minus 1, 5, 3, 6, 7. So while the q is there and nums of I, the current nums I is greater than whatever is inside q. Okay, so let's print q every time. So where should I print q? Let's print q here. Print I comma q u. Okay, and again print q here. Okay, this video is also going so long. 1 second. IQ dot append. Okay, sorry. So 0 and nothing and nothing. But after this, we are appending I. Okay. Rather trying to print it here, let's do it this at here. So I am popping q of pop 0. So instead of popping it, what I should do? Okay, so 0 initially it is 0, then it will become 1. Yeah, it will become 1, then word 2 will come. Okay. The problem is I am popping the last index. This is not true. We can't pop because answer the same answer could apply to multiple windows, and I shouldn't be popping it here. Okay, I should have used q of 0 instead. So we can print directly this q. We don't need this printing this q. Okay, match. Does it not match q0? Okay, yeah. So nums of q of 0. Yeah, it will work now. Shift. It's showing the same problem again here. So it worked. Okay, let's see on the code is like I guess you while seeing my struggle with the question, and when I was trying to tell you that what we have to do is whenever we have k windows, okay, whenever we reach the first window's end, so this is the end of first window. From here we will start appending everything whatever is at the first element of q. Okay, that's what we have to do. So every time I will be doing it and it will work. Okay, so what if, yeah, this one, okay, q will append I. Okay, let's try to submit it directly and see. Oh, got submitted. Okay, so I guess let's discuss it at last again. So let's discuss the code again. So what I'm doing here is taking a queue. You can take a deck also, because it is saying memory usage is 86% and it is only faster at 49%. Now if I would have used deck, it will be like, this will increase, okay, and this will decrease. You can try it yourself and write it in the comment whether it worked or not. So taking a queue, I'm taking a queue to keep track of max values index. Okay, now this is our result. Okay, no problem. So here I am iterating it, and here I am removing the solution, which, okay, one more thing. We should have used one more thing or not? No, it is okay, because we don't need to check whether the difference between q minus 1 and I is greater than equal to k or not. This part is taken care by this if loop, sorry, this one. Whenever I minus q q is equal to k, it will pop it, no problem. K is equal to k, yeah, it will work, because every time appending I'm only one of the element now. So after removing the solution, removing the value which is contiguous, which is less than current value, directly you can write less than current value. Okay, here I have done this, and finally I appended the current one because it can be the answer of the current window. Append the current values index, current values index. The next is check whether the current, okay, check whether the first element of queue lies in the window or not, lies in window or not. And then if it is not lying in the window, then pop it. There can be only one element because we are appending one element at a time, so there can be at max one anomaly. And then finally, if I is greater than equal to k minus 1, then this is for every iteration we will get our answer. For every iteration we will get our answer for ith index, okay, ith window. Yeah, so this is done. If you have any more questions, you can ping me or comment in the YouTube channel. Okay, thank you for listening. Let's pack it up and we will meet with the new question. Thank you guys.